Good afternoon and welcome back to Architect Live. My name is Ned Kramer. I'm the editor-in-chief of Architect Magazine. And it is my pleasure to introduce our next session, which is sponsored by our great partners at reThink Wood, an important organization in the architecture space promoting the benefits of, what else? Wood. And they have convened for us two very interesting speakers. Jeff Morrow, who's a construction program manager at Lendlease, the international organization, and Tom Chung, who is an esteemed principal at Leers, Weinzapfel Associates. Gentlemen, take it away. Thank you for joining us.
Thank you. Thank you, Ned. So thank you for inviting me to speak about wood and how we might rethink wood. A lot of people have conceptions about what wood is, and so I want to give a brief introduction about why wood, why now, and what is possible. So we know that wood is a renewable material. Trees grow just like human beings. Starts as a sapling and then it matures. And when people think about using wood, they might see an image like this where they see a forest that has been harvested and they might think, wow, that's not so good. But with sustainably managed forests, that's that same forest 5 years later with trees starting to grow back again. And in about 20 to 30 years, that cycle can be repeated. And this is why wood is a renewable resource that can be used for as long as we can conceive. And so the other aspect of wood that is really interesting is something that we all learned in kindergarten when we were told we breathe out carbon dioxide and trees are good for you because they take the carbon dioxide that we breathe in, that we breathe out, and then they produce oxygen. Well, where does all that carbon go? Well, it gets stored in the wood as it grows. And so there's a fancy term, carbon sequestration, that's used a lot, which means basically the storage of carbon. So the more that the wood can be harvested and used as a building product, in which that carbon can be stored in the life of the building for up to hundreds and hundreds of years, that's all that carbon that's not being released into the atmosphere. And as many of us know, carbon emission is one of the major factors of global warming and climate change. So this is a really important reason why wood should be considered as a building material. The other aspect of it is the embodied energy, what we call all the energy that's used to produce any building product, and from extraction to processing, transportation, construction to disposal. And with wood, it has a very low embodied energy. It's essentially just debarking the wood, cutting it up into lumber pieces. In mass timber, we might glue it back again, but it's a process that does not involve a lot of energy, a lot of combustion, or high heat. So you might ask, why does it all matter? Why do we care about this? Well, the buildings account for about 48%, nearly 50% of the global energy use. It's a very important factor. And the global industry accounts for 40% of consumption of resources, emission of greenhouse gases, and 40% of solid waste generation. And the more that we can build responsibly then as building professionals to counter this, this is a very responsible way of building. And as we know, it's projected that by 2050, 70% of people will be in urban populations and cities. People are moving back into cities. And also in US alone, 70 million new homes. So there's a lot of opportunities to build and to build responsibly. So the other aspect of it is what is possible now in wood. When people think of timber, maybe this image comes to mind where you have a chainsaw and a log and you kind of cut it up. And you can make beautiful log structures like that. We've all seen structures like this. But mass timber, advanced timber technology is something quite different. This is an image of cross-laminated timber panel, and it's a highly engineered product that's produced in a very controlled environment in the shops. And it's all controlled by computers, digitally fabricated. Here's a panel of the CLT being cut. And the possibilities are endless to designers and architects such as myself in terms of what you can do, all the different joints and the cuts that can be made so that you're very limited by your imagination only as an architect. So you can make complex joints like this, which would not have been possible 20, 25 years ago without all the revolution in digital technologies. And that joint is a joint of this very complex structure of glue lamp structures that's going up at Art Gallery of Ontario. Here's the finished product. Not only can you do complex structures in wood, but you can do long span structures in wood, such as airports. and you get the beauty and the warmth of wood spanning a large space. And something that's been talked about a lot, tall wood. You can now go tall and build high-rises in wood. Here we see an 18-story building being built in British Columbia. And as an architect, I've had the honor of using cross-laminated timber and mass timber in a recent project that we just completed. It's the design building at UMass Amherst. Here's a photograph of the main central space. And as this diagram shows, most of the structure, almost all of the superstructure is wood. It uses cross-laminated timber for floor panels and glue lamp structures for the columns and the beams. And it does use concrete, and it does use steel for cantilevers. So it's really, as an architect, a responsible way or a smart way of using materials for their best properties. And as I've just shared, wood is a very important component of that. Here's the overall section of the building in which you can see the large spaces, the studio spaces, all the wood that's exposed, to the small offices where also then we take advantage of the warmth of the wood, and the main central spaces where we had an opportunity to do something really special. The building is clad in a copper-colored aluminum, anodized aluminum panel. You can certainly expose wood, but it requires periodic maintenance. So in our case, we decided to clad it, but in a way, in a color and a tone that sort of brings back the color and the tonation of the bark of the tree, exposing the lighter cut wood that's on the inside. It also had to do with the context that was in among the historic brick structures that were on the site as well. And as our building shows, and this image shows probably best, it's a building with lots of different angles, geometries, complex geometries, cantilevers. So what we're really saying is that wood has a lot of possibilities. You can do complex forms, and it's not just rectangular towers that are the tall buildings that can be done, but really any program and any type of building that you can imagine or the client needs can be translated and done in wood as well. And then you could also then expose, in our case here, visually the wood while protecting it behind glass, so that as you approach the building, you can see that it is a wood structure. And then people really enjoy the warmth of the spaces that natural wood, and by having it exposed, it creates. Here's a studio space, a bright day-lit fill structure where everybody really loves the warmth and the comfort of the natural quality of wood. In the central space, as I said before, was an opportunity for us to do something more dynamic and structurally interesting. So we did a series of trusses to span the largest span of the space. And what that creates then is an opportunity for structural elements, not just to be structure, but also to be aesthetic elements, combining really the structure, the necessity of structure, as well as the aesthetic implications and the qualities of architecture. So really the architecture and structure becomes one, and it's really to be celebrated. We call this, in this view, which describes it the best, a zipper structure, because all the members of the truss comes to a single point in the middle and lines up, much like when you're closing a zipper. And again, a detail of that from looking above, and really the craft and the dedication and the collaboration, the coordination that's required among the structural design engineer and the architect to achieve this together. So I think we were really excited when it was featured on the cover of the Building Design and Construction magazine as part of an article that highlights all the recent buildings in mass timber, and really a way, for the reasons I've expressed to you guys in terms of all the environmental benefits, that it's really can be a potential game changer in which we can really start to think of wood again as a building material for all types of buildings. So thank you very much.
Tom, that's a beautiful, fantastic project that you've done there. It's very noteworthy, and I can't wait to show some clients what you've done on that one. So I'm Jeff Morrow. I'm with Lendlease. We are a large commercial construction management firm as well as land development company, and we have offices around the United States. And what I'm here to talk about is how we're utilizing CLT in the United States. We've pioneered the use of it in Australia as well as in Europe. And at one point in time, we had the tallest wood building, Forte, a 10-story building in Melbourne, Australia. But here in the United States, we've gotten our feet wet with going with mass timber, and we like what we're seeing. And this last year, we completed the construction of a new hotel for the U.S. Army. It's a Candlewood Suites Hotel in Redstone Arsenal, Alabama, near Huntsville. And this looks like just a regular hotel that you would see in the suburbs. It complies with the brand standards for the Intercontinental Hotels Group. It looks like a hotel you'd see anywhere, and then on the interior it looks the same. And so what we're finding is that CLT doesn't necessarily have to be exposed. It can be concealed. It can be a rudimentary structural material, and it gives a lot of flexible benefits in that regard. So this is what we did at Forte, 10-story building, 9 stories CLT over a 1-story concrete podium. A lot of it was concealed, but then we did leave some exposures of the CLT for aesthetic effects, including the balcony as well as some of the accent walls. And then this past year, we've been building a 7-story commercial office building in the central business district of Sydney. And it's all exposed glulam and CLT floors and for the floors and deck. A beautiful structure in the middle of downtown Sydney. And we're also going to be doing a 15-story building in Brisbane as well later this year. But for us in the United States, we're starting to see after the Great Recession, a lot of the construction workers left the workforce, and the opportunity to deliver on those projects has been challenged a bit. And the workers haven't come back after the recession. Meanwhile, the construction sector has boomed. And so what we're starting to see with CLT is that when you start to have multiple factors that could be in your project, we're starting to say that CLT should at least be considered as a viable building material. What we found so far with CLT is we can build faster than with conventional building materials, and we're building it with fewer people as well. So labor scarcity is an issue, especially skilled labor is a serious issue for us. And then if you have areas where you have poor bearing capabilities for your soils, you can do a concrete building weighs significantly more than the CLT frame structure. And that's where we got started with it in Australia because our soils had poor bearing capacity there. So instead of doing a lot of remediations for your foundations, if you can just build a lighter building in the same space, that saves money and accelerates your schedule. For us, we're looking at CLT as an opportunity, as a viable building framing system in the 6 to 10 story range, actually up to 12 stories. It can be engineered pretty easily up to that. And that's where we see it differentiating itself from traditional wood framing, as you can see here from this slide. And the uses for this could be a variety of different things. It could be residential apartments, condominiums, it could be offices, exposed space, it could be educational spaces like Tom has done for the University of Massachusetts, and hotels. And it can be, again, concealed or exposed depending on what your desires are and what your performance requirements are for the building. So, a couple pictures of what we did at Redstone. We started to frame our structure on Friday the 13th of all days. This is our stair shafts that we did. The first two wall panels of our stair shaft, those panels were 8 foot by 37.5 feet long. And it took us 13 hours to set that stair shaft. And the next stair shaft, it took us only 8 hours for the same size, and the next elevator shaft took us 5. So what we're seeing is the speed of construction is significantly faster than had we done this out of concrete block or just concrete doing your lift jacks forms. So we can assemble this quickly and keep going vertical as needed. Here's a picture of our first floor area. We had a lot of columns and beams in this lobby area, and you can see the floor deck getting hoisted up on top of it. Our typical floor panel was about 8 feet by 50 feet, 400 square feet, and we could set a panel every 12 to 15 minutes. So every hour, we were setting 1,600 square feet of floor deck that was trade ready for the workers to go work underneath it. They didn't have to worry about anything falling on them because it was 7 inches of wood. Nothing's going to go through that. And everywhere they looked, they had a wood stud that they could screw to make their anchorage and connections to. So our follow-on trades were much faster. Had we done this building out of concrete, normally you have to get up to the 4th story before your subcontractors can go in because of the shoring and the reshoring. In this case, you need to give us a half a day, and then you can be right behind us as we start setting the floor panels. Actually, I'll go back there. You can see the elevator shaft there in the background as well. Also 3 stories already framed in 5 hours' time. Here's a view looking down the corridor. When we basically said that the walls were solid wood, we meant it. The corridors, as well as the demising walls between the rooms and the exteriors, were all CLT. Then there would be some infill for the bathrooms and the closets that would have been on the traditional metal stud framing, where that wasn't necessarily for a load or shear application. But as you can look down here, everywhere you need a stud to anchor into, you have it there. Here's a view looking at the building after the first floor walls are up. As we're starting to do the second floor level, you can start to see the second floor slabs where it terminates at the guardrails, and you can see all the shaft walls already up and completed. There's a close-up of what the elevator shaft looked like with the divider beams also made out of wood, quickly assembled. So for us, CLT is a different mindset and approach. It's not it requires a lot of collaboration up front, a lot of detailed decision making up front. We kind of joke that it's a set of Legos or Lincoln Logs or it's an IKEA building in a box. It's flat packed, but the instructions are clearer and easier to understand. But it takes a lot of time and effort to put this together, to make your decisions up front. But we find that it's really worth it because what we found out is that when we were doing our portfolio of hotels for the U.S. Army under our privatization agreement, we were building identical hotels out of a metal stud and concrete configuration, basically the same size, and we had a past performance of about 5 different hotels that we could compare against as to what they did. And in this case at Redstone Arsenal, our hotel was actually 14% larger than the average size that we had built previously. And the size of those buildings had grown because of the programming needs, not necessarily because of the wall thicknesses of the CLT. But you can see here, looking at it, we would have had a peak crew of 26 carpenters that would have been up there building that project. And then what we did at Redstone Arsenal is we did it with 11. And not only did we do it with much fewer people, we also did it 37% faster than our historical averages had been when we did it out of metal studs and concrete. So when we were able to start shaving serious time out of the critical path of the schedule by utilizing cross-laminated timber, and then I also mentioned up there modular construction, we utilized prefabricated bathroom pods. By putting all that in, we shaved 3 months off the schedule. That was 3 months earlier saving, 3 months additional revenue for our client. It was 3 months reduced general conditions as well. And all that collaboration and decision making up front led to very minimal change orders later, which led to a nice cost certainty for our client as well. So when you look at that, when you get the precision of the building as well as the lack of change orders and the speed, all of a sudden it seems to make a lot more sense, provided that you're willing to collaborate and make those decisions up front. And for us, because we had a repeatable portfolio of work, that was very easy for us to do, but that could easily be translated into any other projects in the construction sector, so long as you have everyone ready, willing, and able to commit and work together and collaborate. But we did it faster with fewer people. And that's what really stands out with us. And the precision was incredible because the CLT panels were made to a 2mm tolerance. And we didn't have any issues in the field. The pieces just went together the way they should be. And we think that this is going to work very well for tight urban environments because when your truckloads come in, your panels are reverse loaded in the order that you need them. So as soon as you connect your cables to it and you hoist it into place and you set it and you keep going. So your semi-trucks just keep coming through. As you empty them, a new truck comes in to keep filling your panels. You don't hear the sounds of concrete trucks and concrete pumps. It's a much quieter site and it works very well for tight urban situations. And for us, the benefits of CLT, of utilizing mass timber for it, is we found it was 37% faster than traditional metal stud construction for the military applications, and it was a cost neutral as well in that environment. On the military installation, it has to be blast resistant so that it could withstand a bomb blast either from the outside, from a pickup truck bomb or a suitcase bomb that's brought inside of the building, and it would be designed to resist progressive collapse. So it's a very robust building. And we found it also that it was going to be modeled to be 31% more energy efficient than buildings of traditional mediums because of the air tightness of the building as well as the thermal massing that was provided with the structure. And because it is wood, it had 1,276 tons of carbon sequestered. So the environmental footprint is better. We found that to be better than what we've done in the past. And then for also the other part of sustainability was the social aspect of it. Is that with our 11-man crew, when we framed the building, we only had 3 trained carpenters. The other 8 were unemployed Army veterans that we hired through an outplacement agency and trained them on the job to become CLT installers. And during the course of the 11 weeks of on-the-job training, they helped us assemble that building. And 11 weeks with 11 men. And what we're finding is, we gave them a skill that they didn't have before. And now they're trained installers that we can take with us on other projects and when we're going to other places. So we're finding that it's an opportunity for skill development for workers who didn't have it before. It's faster, and there's more, with the environmental benefits, it just seems like it's a win all the way around for us. A better product for us to deliver, for us to build safer and better for our clients as well. So here's a picture of looking down on the 3rd floor, and you can see all the walls in place. You can start to see where the floor panels have terminated right there, but what we also see with this environment is that you can work in it in a variety of conditions. It can be cold, it can be warm, it can be rainy, it can be dry. You can still work in it safely, which other building materials can somewhat be a little bit more challenging. Here's a picture of the floor panel going in. It's 8 foot by 50 foot long, about 8,000 pounds. And again, we're setting those every 12 to 15 minutes. The guardrails are already in place so that when our workers are up there, the panels are in, they're protected, they don't have to worry about falling down. And here's a picture of the construction as we finished framing the building. And there we are. How do we turn this off? So, I think this is a point in time where we're supposed to be entertaining. Either we're supposed to banter back and forth, or we're supposed to take questions from the audience if you have questions. Ned's got a question.
Yeah, I'm very curious about kind of code compliance and mass timber construction. And so was there anything in working on the hotel, which I understand was obviously a federal military project, but also private, sort of what was the regulatory climate you were working with, and how did mass timber fit into that?
That's a good question. For us, it was easier to work with because it was on a military installation. It was an own independent authority having jurisdiction, and because it was a 4-story building, it was a Type 3B. It was well within the prescriptive ranks of the code, so there really weren't any questions about whether or not it could be built. One of the challenges and the opportunities that we are having in the mass timber industry right now is that we know that we can engineer these buildings to be taller than 5 stories, but right now the building codes are typically, under the traditional path lead to 5, but you can go taller than that if you do the alternate means and methods. And so one of the opportunities and challenges that we're having is meeting with different authorities having jurisdictions, meeting with different clients as to who's ready to push that envelope here in the U.S. to go a little bit taller and start to step out of their comfort zone, out of the box of what has been normally done. So for us, anything 5 and under, very easy to do. It can be somewhat cost competitive challenging and when you're comparing it against a wood stick framing, because wood stick framing is a very economical building material, but in the military application, wood stick framing doesn't apply for blast performance. So we had to upgrade that either to metal studs and steel or concrete. And so that's where CLT had a differentiating advantage. So, but in areas where you have tight labor markets, all of a sudden, even at the 5-story realm, CLT and mass timber could be an economical fix just because of the fact that our labor markets are so tight. Labor is quite expensive in certain markets, and therefore that it can be competitive. I can't use a broad paintbrush that says CLT always works here, it doesn't work there. It's always a slightly nuanced approach that requires an investigation and exploration, deliberation by the client, the architect, as well as your contracting partner when you're collaborating on that.
Yeah, and we had a similar experience as well too, because we weren't a high rise. We didn't have the challenges of the tall buildings have. But in our case, we had to go through a variance process. But it was fairly straightforward because, and this is what I recommend to all people that are interested in building in mass timber and cross-laminated timber, is to get the fire marshals, get the code inspectors involved early in the process so that they're not scared or hesitant about a new building type of material, and that they really become part of the conversation and they're involved early so they feel part of that process. And this is the approach that we took, and really then we got the support of the state building inspector, who then supported us through the variance process that we had to go through, particularly because our building had a lot of complex geometries, and not only were the load-bearing vertical elements timber, but also the lateral shear walls and the seismic elements were also made out of timber, and those things then had to go through a variance process. But it is getting easier and easier. The new IBC, the International Building Code 2015, has now adopted cross-laminated timber so that it will be more of a prescriptive process.
I want to piggyback off what you said earlier about the CLT. Another great component of that is the cantilever condition it has for balconies. And that's something that really you should think about when you're trying to do balcony construction. The CLT can really cantilever itself very well. And the other thing too is when you are doing every job now is so full of safety issues. And so when you come in and you cut your manpower down to half, and if a job is self-engineered or self-allied, you're gonna cut your insurance almost way down by allowing your OSHA insurance to be almost half of that. So something to think about. And then thirdly is if you saw the film or the slide on insulation, you do not have to. Those straps do not go around the beam. They go on top of the beam and held in with a connection. So it's an extremely interesting way to install quickly. And all you do is have a guy there with a drill bit, like you said, someone who doesn't even know what they're doing can learn CLT within a matter of hours. So I just want to piggyback on that.
Thank you. Oh, and we're done. Thank you. Oh, one more question.
Thanks. I wanted to ask, how do you deal with the systems of the building, in particular, like electrical conduits, outlets, and that sort of thing?
You want to answer that?
Yeah, sure. Because wood is a material that can be easily manipulated, it's a material that a lot of people in the construction industry are familiar with. If you want to drill things or drill a hole through, you can easily do that. There are a lot of handheld tools that you can do that. And so the various mechanical, electrical, plumbing engineers and contractors on our project, they love the fact that the base building material, the structure was wood, because it was so much easier for them to then attach hangers and all of the utilities of the building.
For us on our project, we also furred out the walls so that you would have recesses and you would have the areas for the conduit and the shallow boxes to go in. So it's always a balance of what you want to leave concealed versus exposed. I'll show more at 2:30 in the Woodworks Learning Lounge if any of you want to come. I've got more details on that then.
Gentlemen, thank you so much. I learned a lot, and I'm sold. If I was specifying, you'd be in business. So that was Tony Chung from Leers, Weinzapfel, and Jeff Morrow from Lendlease. Thank you, gentlemen, so much for a very enlightening presentation.
Thank you.
Thank you.
Thank you.